Welcome back, students. In this video, we will be talking about the logarithmic functions. The logarithmic function, as per definition, are the inverse of the exponential function. And what do we mean by inverse? That means in a function, x is replaced by y and y is replaced by x. Therefore, it has its own properties, and as it is a function, it would have its own restriction, its own domain, range, y and x intercept, and also its own asymptotes. So here, the notation that it's used is y equals log of x to the base b. Okay, so here, the first restriction that we have is the x must be greater than 0. So it cannot even be 0. It must be greater than 0. Okay? In other words, this expression here, okay? This expression here, whatever it is, it must be greater than 0. So here, y is the value of the logarithm x, okay, and x itself is called the argument, and b is the base. Okay, so the b is the base, x is the argument, and y is the value of the logarithm. So as I just mentioned, the argument must be greater than 0. So if the argument is an expression, that means the expression itself must be greater than 0. So let's say if we have log of x plus 1 to the base b, then the x plus 1 must be greater than 0. And remember, this b is exactly the same b that we were discussing about in exponential function. If you remember, in exponential functions, we had f of x, a, b to the power x. So this b, the base, is the same as this one. And later on, I will show you how these two are related to one another. So let's reiterate the restrictions. There are two important restrictions, as you can see. The arguments can never be negative, or it can never be equal to 0. So it must be greater than 0. Okay, so the base must be greater than 0, and then it cannot be equal to 1. So there are two restrictions for the base, and there are two restrictions for the argument. Okay, now let's talk about the different types of algorithm. There are two very important common ones. One is the natural log base, okay? So the base is e, exponential, and the other one is to the base 10, okay? Even if you open your calculator, you will see these two. So if it is the base 10, we use log. And if the base is 10, we usually do not put the base. The other one, which is called the natural log, which the base is letter E, it is written as ln x. So log to the base of x, where x is a placeholder for the argument. Okay, so this is how we usually show it. F of x, that means a function in terms of x, is equal to log of x to the base 10. As I just mentioned, when it's base 10, we usually do not write it down. So it would be log of x. The other formula, which is very super important, is f of x, a function in terms of x, is equal to log. Okay, this time we have log, but if you take a look at the base is letter E, right? So it's exponent. Then it would be called ln of x. Please highlight this formula and the one in the previous page. These are super important because most of the times students get confused between these two, but actually the rules are exactly the same for logarithm and ln. And if later on you find working with ln really tricky, you can replace it with logarithm to the base e, because as per this formula, ln is logarithm to the base e. Okay, now the next step is graphing the function. So this is your function y equal ln x, and x is your it's your independent variable, and y is your dependent variable. And remember, I told you as a general rule of thumb, whenever you want to do your graph, so you give values to x and then you find the corresponding y values. Let's do the same here. So we do x and y, x, y. The values I usually pick is like very small values. So remember guys, for the x we had a restriction which should be greater than 0, right? And then okay, so the values I have to pick for x must follow the restriction. So I will pick 1 to 10. I pick 1 to 10 because this is the first time I'm doing the graph for logarithm or ln. I will be using more than 2 or 3 points, so I would have a good idea of the curvature. The other point I will pick is e and then half. Okay, so if you put x as 1, you will see that ln1 is equal to 0. ln2 is 0.7, ln10 is 2.3, ln e, this is how you write it, it's equal to 1, and ln 1 over 2 is negative 0.7. Okay, so these are the points. 1.7, oh sorry, 1 and, so the points are 1 and 0, 2 and 0.7, 10 and 2.3, e and 1, 1 over 2 and negative 0.7. Okay, so how many points? 1, 2, 3, 4, 5. Now we have 5 points. Okay, what we have to do, we just go into our engineering paper, we find the points, and then we connect it together. So let me do this line, and let's do the other line. Okay, and this is the one, this is x, this is y, and the points are 1 and 0. So 1 and 0, the other one would be 2 and 0.7, which is something around here. Now 10. 6, 7, 8, 9, 10. And 2.3, which is somewhere around here. The other one is E, which is 2.7 almost, right? E and 1. So that would be around here. 1 over 2, negative 0.7. So around here. Point. Now what I have to do, I just have to connect the points together. Hopefully I'll try to do a good job. Okay, so y is equal ln x. Now you did it. You can visually see, you can see how it looks like. Now let's talk about the domain, the range, and other properties. Okay, so remember guys, the domain was all the values of x that your function can get, x values. So if you take a look at here, the values that your x can get, see, it starts from here. It's never 0, but it's greater than 0 all the way to positive infinity. So your domain, as per your graph, first of all, the x can be every real number, but the values are greater than 0. Now let's talk about the range. Range of your function refers to the permissible or accepted y values. So you can see your graph here. You can continue it all the way down to negative infinity, right? And then this one doesn't stop here. It goes up, 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 up. So it literally goes all the way to positive infinity. So your range, it's also real numbers, but all the real numbers. Okay, so the next one is your x-intercept. The x-intercept, it's when, remember, when we're talking about the x-intercept, the y must be equal to 0, okay? So in here, the x-intercept, it's exactly here, right? Which is at 1 and 0. So your x-intercept, it's at x1. Now, what is your y-intercept? Is there any interception with the y-axis? Let's go back to the graph. As you can see from the graph, there is no interception with the y-axis, right? By definition, y-intercept is when the x is equal to 0, but there is none y-intercept, right? Okay, talking about asymptotes. If you take a look at here, the graph one more time, consider this line, the vertical line, the y-axis. You will see that the graph, the pink curve gets so close to it, but it never touches it. So the y-axis is actually the vertical asymptote, right? There is no horizontal asymptote, but there is a vertical asymptote. So let's see, in terms of asymptotes, you could say the vertical one, there is a vertical one, it's the y-axis, and the equation for the y-axis is x equal to 0. So it's very important for logarithm to know their properties and the rules, so you know how you will be able to actually how to use them and how to manipulate them to solve different types of question under logarithm. Okay, now if you go to the next page, we will be talking about the properties of logarithm. Again, this is a very important very important formula. I want you to highlight it. This formula actually tells you how to convert between an exponential and logarithm. Exponential, logarithm. So this runs both way. Okay, if you have the exponential, you can use it to get the logarithm and vice versa. And you see that the b is the same thing. It's the base, y, and x. Okay, so here in the next example question, you're asked to write the following in exponential form. I want you to pause the video here, try to solve these questions, simple sample questions, because I know it's very simple, but remember guys, when you're introduced to a new topic, you should start by, doing some very simple questions to get fluent and find the mastery, so you can do it fast, in more complicated questions. So here, pause the video, try to solve all of these, then I'll answer the questions for you. Okay, so the first one, you have the exponential form, and you want to change it to the logarithmic form, right? So you have the y, you have the base, and you have the exponent. Let's put it in the logarithmic form. X would be log, right, y, but the base here is what? Exactly, the base is 2. For the next one, the base is 10. Okay, so again, x is log y to the base 10, or remember, whenever it's base 10, we can just simply not write it. The next one is 2 times 10 to the power x. Compare this to this. Okay, so if you want to use a formula or a template, and you see there is some deviation from the template, you have to make sure you change it, you manipulate it, or to get the original shape or the original configuration or original arrangement in the original formula. So here, y equals 2 times 10 to the power x. I have to just make a little bit adjustment. Y over 2, it's 10 to the power x. So here, instead of y, wherever there's a y, you have to substitute it with y over 2, right? So let's do it this way. X would be log, right? The base is still 10, okay? But here, that would be y divided by 2. Or you can simply write it as y divided by 2. Okay, students, let's continue with the next example. This example is very similar to the previous one. The only difference is that here we have -2 instead of +2. So I can just copy the answer here. It would be minus y divided by 2 to the base 10. Or remember, guys, what I told you, if you have base 10, you can just not write it down. The next one, it's y equals 7 to the power 2x. So here, the exponent, instead of x, it's 2x. So when you want to convert it, that would be 2x would be log, right? Log of exactly y to the base 7. Or you can divide both sides by 2, and then you could say x is equal 1 over 2 log y to the base 7. Now, the next one, here you have a coefficient before 7 to the power 2x. So here, what you have to do, in here you would have 2x, right? The only difference is that here you would have log. Instead of y, you would have, what is it? Perfect, 2y. 2y to the base 7. You know what I did here? Here I just multiplied this side by 2y. So 2y equals, that's what I did. 2y equals 7 2x. So if you compare this one with this one, if I want to use this formula, instead of y, I just write it 2y, right? So moving to the next topic. In here, we're doing more practice actually. It's very similar to the previous part. Here, we have logarithmic. We want to change it to exponent. So it's exactly the same thing, the same formula. It just matter of more practice. So here, you have a few examples. They are written in logarithmic form, and you want to change it into the exponential form. Remember here, when you have log of an x to the base b equal y, when you want to change it into exponent, that would be b to the power y, right, equals x. So here, As I'm a visual person, so this is how I usually do. I go, this is the base, this is the power. So that would be 2 to the power 4 equals 16. Okay, so again, I go, this is the base, this is 2 to the power 2 equal 25. These first few examples are very easy kind of because they are numeric values, and you can, after changing it into exponential form, you can actually see that the two values are exactly the same on both sides. So here again, the base is 3 to the power 1 over 2. Yeah, it's a square root of 3. Okay, next one. Now, here 7 to the power negative 2 equals 1 over 49. Exactly. So, next one. This is your base. First of all, find your base. So, that would be 6 to the power negative 2, and the answer is 1 over 36. Right? You have to be really good from in changing from one form to another. Another example is here. You can see here the base is not written. So when it's not written, it's actually 10. 10 to the power x is equal to 1/3. Okay. So here you can memorize this thing. It's up to you however you want to memorize it. The logarithm is the exponent y to which the base b is raised to obtain the argument x. Okay, now the next part, I'm giving you a table. This one is more for practice. So I given you the logarithmic form, the 1, 2, 3, 4. As you can see in one column, there are 4 of these. And I want you to change it into the exponential form. Okay? Then in the third column, if you see closely, there is a relationship. Like, can you see? You can relate the first column to the third column. And also here, you should be able to relate these two. Okay, so here I have logarithm 81 to the base 3 is equal to 3. So if I want to write the exponential form, 3 to the power 4 would be 81. And then here I have logarithm 1 over 81 equals to the base 3, right? So 181, okay, to the base 3. Actually, this one, sorry guys, this one should be 3. Okay, so the answer should be, remember guys, what I told you, if this is the base, it should be raised to the number here. So from here, you could see that the number should be -4, right? So here, logarithm 9 to the base 3 would be perfect, 2. Now here, if I want to write the exponential form, that would be 3 to the base to the power 2 would be 9. Okay. Now, how about the other side? Okay, so logarithm, what is the base here? 3. Okay, -2. Remember, guys, I told you I'm a visual person. I'm doing the opposite. This raised to this power would be equal to here. Now, let's do this one. Logarithm 3 to the base 3. If you put it in your calculator, you will see that it would be 1. Now, if I want to write it in exponential format, the base to the power 1, it's equal to 3. Now here, I have this side, and I want to change it into logarithm. So, remember guys, base, -1, and here 1/3. Okay, now, logarithm 1 to the base 3, yes, 0. So here you would see that base to the power 0, it's 1. Okay, now, how about here? So here, for 1, right? Even if you reciprocate it, it's still 1, right? So it would be still 0. So even this side here, that would be exactly the same thing, because the reciprocal 1, it's still 1. Okay, now the next table would be for your practice. I want you to, you know, solve it and make sure you understand the concept. Okay, now rule number 3. If you remember, rule number 1 and 2 was conversion between the logarithmic and exponential and vice versa. Rule number 3, it's when you have the argument and the base are both of these are exactly the same value. Okay, so here when these two are the same number or value, it will always be equal to 1. So to give you an example, log 5 to the base 5 is 1. Log 10 to the base 10, right? It's 1. Okay, how about this thing? What is it? Exactly. Remember, ln, it's actually log to the base e, right? And here it's e, so log e to the base e is 1. Okay, so these are very important properties or rules. So rule number 4, please, if you please highlight this one. This is very important. The power law of logarithm. So when you have a power here, let's say x, you can see here x, this x will move to the front. Okay? So remember guys, here you only have one term. And that term has got a power. What you can do, you can move the power to the front of the logarithm. Can the power be negative? Yes. Can it be any real number? Yes. Okay? But remember, there is only one term. So here, as you can see here, so you can just move the 5 to the front. So that would be 5 times log n to the base 8. For the next one here, what is it? So you can do the opposite, right? So you could say this is 8. Now you can move this 2 as a power, right? We're just practicing with the power. So here the next one is the 7. Remember guys, the ln and the logarithm are exactly the same thing. So they have the same rules, right? If I here introduce the rules of logarithm, you can easily apply them to ln or natural logarithm. So here this would be 7 ln 10. Okay, now that you learned about this rule, I want to draw your attention to this thing. So here, as I just mentioned, you only have one term. So this rule is different to this thing. Okay? This rule applies when you have the x as a power of a. But here, the x is the power of the product of the logarithm, right? So whatever is the product, you have to raise it to the power x. So these two are totally different. Remember guys, for here, you cannot just easily say, hey, I can move this x to the front, blah, 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 right? This is totally wrong. Okay. Just to give you a hint, because remember down the line, we should be able to solve, right? We should be able to solve logarithmic equation. So here, let's do it this way. You will get the typical questions you would get. So let's say 7 to the power x would be equal to 2x plus 1. They give you such an equation and there you're asked, okay, to solve this equation. So if you want to solve this equation, you have to use the rules of logarithm, right? Because this equation, you cannot solve it from other methods that you learned so far. I mean, like, it's not linear, it's not quadratic. If you want to graph it, it would be very difficult, right? Because you're not familiar with the general shape, and therefore you have to be really exact. So here, what method works best? It's taking log of both sides. I'm gonna I'm gonna talk about this type of equation in here because you can see how I'm using these rules. So you take log of both sides and here log of this side. Okay. So if I want to rewrite it and make it really nice and neat, this would be log 3 to the power 2x plus 1, right? So what I want you to pay attention here is that if you take log, the bases must be the same. If you want to use base 5, 6, 10, it's up to you. But whatever base you use, it must be exactly the same. But the easiest base to work with, it's 10. If you're given a choice, the easiest base to work with is base 10 because your calculator can do base 10 in one step. So here, let's say logarithm 7 to the power x. On one side, on the other side, you have logarithm 3 to the power 2x plus 1. What you can do here, you can use exactly this rule, right? And you can move this power to here and this power to here in front, right? So it will turn into x log of 7 equals to 2x plus 1 log of 3. And remember, guys, these are in base 10, so you can just put it in your calculator, find the value of log 7 to the base 10, okay? And then on the other side, you can just find the value of log 3. So if you put it in your calculator, you can easily find the value of log 7 and log 3. So this will turn into an easy linear equation. 0.84 times x equals to 2x plus 1, 0.47. Right? From here, you can move this thing 2 times x times 47, it's 94. Okay? Comes to this side, it would be negative, so that would be negative 1 point x is equal to 0.47. So the x would be 47 divided by 10, negative 10, which is negative 4.7, right? And this is how you can solve it. Okay, as you can see, there are some more practice questions. So here, what I can do, 125 is 5 to the power 3 base is 5. So this 3 will move to the front. That would be 3 times log 5 base 5. And remember, this was rule number, I think it was rule number 3, right? Same base rule. So b to the power to the base b would be 1. So here, what you can see, this is 1. So the answer is 3. Next one here, you have 1 over 32. I'm going to write it as a side note. 1 over 32 is 2 to the power negative 5, right? So here, log 2 to the power negative 5 to the base 2. Negative 5 moves to the front. That would be log 2 base 2. So the answer is negative 5. Now here, you have log 3 to the base 9. But what you can do maybe here, because remember, guys, we want to use the laws we learned so far, right? So here, what I will do, instead of 9, okay, instead of 3, sorry, I can write this one, right? Because the answer is 3. And then 9. Okay, so here I would have log 9 to the power 1 over 2 and 9. So that would be 1 over 2. How about here? Okay. Yes. Exactly. So here that would be log 5 to the power negative 1 over 3 and the base is 5. So again that would be 1 over 3 log 5 base 5, which here it's 1. The answer is 1 over 3. Now next one. Yes. So I'm gonna try to skip some of the steps because you guys should be good by now. So here 5 can move to the front and then what I'm left with log 10 to the base 10. So it's 5 times 1. The answer is 5. Here square root of 10, it's 10 to the power exactly. So it's 10 to the power 0.5. And remember, whenever the base is not written, it is 10, right? So that would be 0.5 times by 1. The answer is 0.5. Now again here, log 0.01. This is log 10 to the power negative 2. So the answer is negative 2. How about here, guys? So that would be 3 ln e. And remember, this was 1. So 3 times 1 is 3. How about this thing? Ln e. The power is 2 over 3. So 2/3. How about here? First of all, okay, I move this guy to the numerator. And then the answer is negative 4. Here, that would be ln e to the power, yes, negative 1 over 2. Here, log 10 to the base 10, it's always 1. Now here, 2 log 10 base 10, the answer is 2. Okay, a few more examples. That would be negative 2. I leave it up to you to find the answer. Here, the answer is x. Now here, what do you guys think about this one? Okay, you wouldn't be able to solve it with the knowledge that you have because here, remember guys, you have 3 multiplied by 2x and 3 cannot be written as a product of as 2 to the power something. So for this thing, you need to know another rule. I just leave it for now. Now I will move to the next one. Take a look at the next one. See if you can solve it, right? So even for this thing, your current, let's assume you don't know anything from before. So your current knowledge, you wouldn't be able to solve it because here you cannot deal with 3, right? 1 over 3. You cannot rewrite it or convert it as 2 to the power something. Therefore, let's introduce the other rule. Okay guys, now rule number 5 of the logarithm, it's called the product rule. Remember, this is a very interesting rule. In here, on this side, you have log x multiplied by y, but on this side, it will be as sum of log plus log. Okay, so the product rule will be changed into addition of two or more logarithm. Okay, so on this side once more you have x multiplied by y, but on this side you have log of something plus log of another. Okay, now let's solve it together. Let's do some examples. Okay, so here I have log plus log, and remember guys, the base should be consistent. So here if you have base b or whatever, the other should have also the same base. So here, if I want to use this rule, this will turn into, first of all, let's write the base, and here it will change into 6x. How about here? You have same base. First of all, check the base. Base is 3. Now, you have x plus 1 multiplied by 7. How about the other one? So you have b and b, the bases are the same. So logarithm b, okay? Now the base, so here these two will be multiplied, right? Perfect. Now the other rule, it's called the, yes, quotient rule. This is also a very important rule, and it is different. It's usually different from what you have seen before. So here, if you have log x divided by y, it's quotient, okay, to the base b, which could be anything. On this side, you would have log x to the base b minus log y to the base b. So again, here it's very important that all of them have got the same base. If they don't have the same base, you can't do anything unless you convert the bases, right? So remember, guys, whenever you want to use these rules, you have to follow the exact template. So here, take a look at these examples. So here, these two are subtracted. Okay, so this is the quotient rule. That would be first one over x base b. How about these two? So these two, the base is 3. So I have x plus 1 over 7. How about this thing here? The base is b. So I usually write down the easiest first. So I know I'm done with. So here the base is b. So I just write it down quickly. Then first one divided by second one, right? Okay, now the next question is asking you to express each of these practice questions as a sum, difference, or multiple of logarithm. So the next question is asking you to use your knowledge, whatever you learned so far, okay? So let's say here, 14, I can write it as 2 times 7, and then the base would be 3, right? So what I can rewrite it here, remember guys, this is the product rule. Okay, so I can write it as log 2 to the base 3 plus log 7 to the base 3. Perfect. So next one, this is quotient rule. So I can write log 2 to the base 3 minus log 11 to the base 3. Now let's do the next one. So here, this is the power. It will move to the front, right? Here, oh my God, this is amazing. So this is a combination of what you learned so far. So let's do it step by step. First of all, you have to use the quotient rule. So that would be log xy to the base 2 minus log, right, z squared to the base 2. Okay, now what do you have here? Product rule. So you can say log base 2x plus log base 2y, right? And here, what you can do, remember this guy, this can move to the front. So that would be minus 2 times log, that would be z, the base is 2. Okay, next one. So here again, I will deal with, like, let's do the quotient first because it's a quotient. So y cube root, okay, minus log 7 base 4. So for this one, this will be 1/3, right? So that would be y to the power 1/3 base 4 minus log 7 4, right? So again, I can simplify it further. This 1/3 would move to the front. Y, this is log y, base 4 minus. Remember guys, whenever the log is anything rather than 10, you must write it down. So next one, you have log x 1 divided by 7 to the base 4, so that would be 1/7 log x to the power to the base 4. How about the other one? Here we can write it as log 1 minus log 125, but remember guys, here the base is what? 5. So what is it here? Log 1 to the base 5, it's 0 minus 125, it's 5 to the power 3. Okay, so I'm going to write it log 5 to the power 3, 5. So that would be, this is 0. So this 3 will move to the front. 3 times log 5 to the base 5, it's 1. So that would be negative 3. Okay, now remember guys, in the previous section, there were 2 questions that I asked you. We'll leave it for now. Now that you learned about the product and quotient rule, you should be able to solve these questions. So the first one, as you can see, you can use the product, right? The product rule. So that would be 3 plus log 2 to the power x to the base 2, right? So that would be log 3, 2 plus x. Because this x moves to the front, log 2 to the base 2, it's 1. Now, next question here. So let me write it like this. Log base 2. So here I write it like this because the x belongs to both of them, right? So first of all, I use the quotient rule, 2 to the power x base 2 minus log 3x to the power 2, right? So the first one would be x log 2, 2 minus x log 3, 2, right? So this one would be 1 x minus x log 3, 2. So if you want, you can find the value of log x to the base 2, or you can simply, factorize it. Okay. Okay, guys, remember we did 6 rules so far. Now, rule number 7. So, logarithm of 1 to any base. So, any base. It's 0. Examples would be ln of 1, logarithm of 1 to the base 10, or logarithm of 1 to any base like 2, it's 0. Because remember, if we use the conversion between logarithm and exponent, the base must be raised to the power of 0, so the answer would be 1. Property 8. This is very awkward looking, but very simple to use. So base b to the power itself is another logarithm of something to the base b. So both of them should be the same base. The answer would be x, right? Examples. So let's say 5 to the power logarithm of 100 to the base 5. So these will cancel out. What is left is 100. And remember, there is a condition that should be met, that x must be greater than 0. Another example would be 7 to the power logarithm to the base 7, x plus 1. Remember, this part would be eliminated, so you're left with the answer, which is x plus 1. And remember, guys, whatever you get here, the x plus 1 must be greater than 0. Okay, so property number 1, logarithm of 0 to base b is negative infinity, because I'll show you from the graph. Because if I want to graph the logarithm, so this is x, this is y. Okay, so let me do the graph in another color. So here, this would be the graph of logarithm. So actually, this line would be the asymptote. and this uh, graph will go toward negative infinity. So at point 0, it will go toward uh, negative infinity, right? At point 0, it goes toward negative infinity, right? But it never touches the y-axis. Remember, guys, it gets so close to, but it never touches the y-axis. Actually, the y-axis is the vertical asymptote. Property number 10 is changing bases. So remember I told you that your calculators work with base 10 only. So here, when you have any base rather than 10, this is how you can calculate it. You can do log b to the base 10, okay, divided by log a to the base 10. This is how you can change the base. And remember, the common base that you use, the intermediate, the transition, whatever base you use, I mean this base, doesn't necessarily need to be 10. It could be anything. So let me give you an example. So let's say log 5 to base 2, right? So that would be log 5 over log 2. So here is base 2, right? So another thing, so let's say it could also be x plus 1 to the base 7. So that would turn into log x plus 1 to the base log 7, right? Now, for practice, I want you to use your calculator to find the values of this logarithm. So I'll help you with the first one, and you guys can do the next one. So that because I want to use the calculator, so I use the 10 as the base. So that would be log 7 to the base 10, and your answer should be right. You find the answer using your calculator. Okay. Now for the next question, I give you this number and I ask you to find the ln of this value. So I just want you to learn or practice your calculator skills, right? So I want you to know how to use your calculator, like this one, or this one. But remember, guys, you can, for this one, you can go ln of this number or 4 times ln of this number. It's up to you. Okay. Now the next question is, I want you to verify the given value. So calculate log of 14, add it to log of 0.5, and see if it equals log 7. Again, for part B, calculate log 6, put the value here, and find the value of log 36 multiplied by 0.5 and see if the two sides of equal sign are equal. So next question is, I give you the log and I ask you to find the inverse. If you remember from the first video, exponents and logarithm are exactly the inverse of one another. So here you just have to use the first rule to convert from logarithm to exponent. So I'll do the first one for you. 3 to the power y would be x. The second one here, again, the same thing, right? 3 to the power y. But here this time is 15. So these two sides, logarithm and exponent, they are the inverse of one another. The next few questions, I leave it for you guys to solve it as practice, but I will do this specific question because this is a very interesting question. So here you're asked to express y as a function of x, and then it's asking you to express or state the restrictions. Remember, guys, when I was talking to you about the rules, I said you have to take the restriction really serious. Okay, so here the first restriction is y must be greater than 0. How about the other one? Because here you have 3 logarithms, this one, this one, this one. So the second restriction and the third restriction, so from here x must be greater than -1, and from here x must be greater than +1. So this is -1, this is 0, this is +1. So your x must be greater than this, but at the same time it's also be greater than this, right? So if we want the x to be to satisfy both conditions, our x must be greater than 1. So from these two, your x must be greater than 1 and your y must be greater than 0. So now let's start by solving this expression. So here, what you have on one side, you have logarithm on x. On the other side, you have a logarithm plus another one. Okay, and I want you to use all the rules that you learned so far. Okay, so when you have log of something plus the log of another thing, what does it remind you of? Perfect, it's the product rule. Okay, so you can use product rule and make it one step simpler. So before using the product rule, I have to deal with this 2. This 2, I use it as an exponent here, as a power here, and get rid of this. And then I'll change this side as log x plus 1 multiplied by x minus 1. But this guy has got a power 2. And remember, the base is 5, right? And here I have log 5 and y. Okay, so you have one log on this side, one log on the other side, and both of them, right, have the same base. So what you can do here, you could say, because both of them are log 5, so you can just get rid of this and say y equals 2. Yes, so you can easily say y equals x plus 1 to the power 2 multiplied by x minus 1. Now let's do the b. So here you have log here. You have log here. First of all, let's start with the restriction. So y minus 3 must be greater than 0. On the other side, x plus 3 must be greater than 0. So from here, y should be greater than 3. And from here, x must be greater than -3. What you can do here, you can move this thing to this side, and then it would be log minus another log. But before moving it, I deal with this coefficient in front. So this 2, I will get rid of it and put it here. Okay, so this thing would be log y minus 3 to the base 3 minus log base 3 x plus 3 to the power 2, it's equal to 1. So from here, it reminds you of, yes, exactly, quotient rule. So that would be log y minus 3 x plus 3 to the power 2 base 3 equals 1. So remember, guys, it was one of the rules that when it's equal to 1, that means this part and the base must be equal. Or you can simply say I converted to exponent. I use the exponential rule conversion. So that would be 3 to the power 1 is 3. It's equal to y minus 3 divided by x plus 3 to the power 2. And then you can rearrange it and write it as y. So if I want to rearrange it, that would be y equals 3 times x plus 3 to the power 2 plus 3. Okay? Now, the next question, you're given logarithm and natural logarithm, right? And you are asked to convert either from logarithm to exponent or from exponent to logarithm. These questions are very simple, but at the same time, they are very important because most of the time when you're dealing with equations or complex big questions under this topic, you should be able to use the very basic rule and convert between these two multiple times. I want you to solve the rest of these questions as practice questions. Then in the next video, I will be doing more advanced questions from here actually. Let's see. So we will solve some of these and these questions and some more. Remember guys, but before doing these complex questions and equations, you have to make sure you know the concepts and you know how to solve them, because as you can see here, then you're asked to solve these type of equation which are not easy, right? And then after that we have to be able to solve the application. So before watching the next video, please watch this video, try to make sure you understand everything, and then I will be posting some questions for you and I want you to solve those questions as homework, then proceed to the next video. Thank you. See you soon.